So in this particular question, we have to find out the value of y. So since they are equal matrices, let's equate the elements. So the first element, 3y minus 6, will be equals to 5. Then we have the second element, which is negative 2x, that's equals to negative 2. From the second equation, we can divide, first we multiply both sides by negative 1, so that will give us twice x is equals to 2. Then we divide by 2, so that would give us x equals to 1. Now what we do, we plug this value of x equals to 1 into the first equation, so that would give us 3y minus of 1 is equals to 5. Then we transpose the y to the right hand side, so we'll get 1 plus 5. So twice of y is equals to 6. Now we divide both sides by 3, so that would give us y is equals to 6 over 3, which is equals to 2. So that's the value of y. Let's go to the next question. This question is similar to the previous one. So here what we have to do for the given equal matrices, we have to find out the value of y. So the quickest way to do is look at the second element, which is twice of y, and we equate them to 0 because that is the second element for the second matrix. So that should give us y is equals to 0. That's the answer. Let's go to the next question. So here in this question, we have to find out the value of x for the given two equal matrices. So let's start by equating the first element, which is x plus of y. It will be equal to 7. And the second equation will be the third element, which is twice of y. That's equals to 4. So we divide both sides by 2. So that would give us 4 divided by 2, which is equals to 2. Now we take this with the value of y, which is 2, and substitute into our first equation to get the value of x. So we have x plus 2 equals to 7. Then we subtract 2 from both sides, and that will give us the value of x, which is equals to 5. Now let's move on to the next question. So it is given that A is a matrix of order 3 by 4. So let me write it down. So we have a matrix A, and its order is 3 by 4. This matrix is multiplied to another matrix B, which is of the order 4 by 3. Now we have to find out the order of the new matrix, which we get after multiplying A and B. So to check this out, so what we do, we see that the column of the first matrix is equals to 4. So there are 4 columns that must be equal to the number of rows in the second matrix. So this is equal, so that means the matrix multiplication is possible. So the new matrix AB will have rows equal to that of the row of the first column, which is 3, and it will have the column equal to that of the second matrix, which is again 3. So the new matrix form will have an order of 3 by 3. So let's go to the next question. So here we are given the matrix equation. So using this, we have to figure out what's the value of k. So we begin by multiplying the first two matrices. So that would be 1 times 3 plus 2 times 2. That will be the first element. The second element will be 1 times 1 plus 2 times 5. The third element will be 3 times 3 plus 4 times 2. The fourth element will be 3 times 1 plus 4 times 5. And this matrix is equal to 7, 11, K, 23. Okay. Let's simplify the values. So that's going to be 3 times 1 is 3. So we'll have 3 plus 4. Here we have 1 plus 10, 9 plus 6, 9 plus 8, my bad, This will be 9 plus 8, 3 plus 20. So that's equals to 7, 11, K and 23. So we have 4 plus 3 is 7, 10 plus 1 is 11, 9 plus 8 is 17, 3 plus 20 is 23. So that gives us a matrix 7, 11, K and 23 on the right hand side. So when we equate each of the corresponding elements, we find that the value of K is equals to 17. So therefore we can say K is equals to 17. Let's go to the next one. So here we're given a matrix A. It's a 2 by 2 matrix. Now here we have to find out the value of alpha such that A is an identity matrix. What's an identity matrix? Now since we're given A is equals to I, then we can write cosine of alpha, negative sine alpha, and sine of alpha, and cosine of alpha. This matrix is A is equals to the identity matrix, which is the first element will be 0, the second element is 0, the third element is 0, and the fourth element is 1. So this is a diagonal matrix whose values are 1. So what we do, so we have to find out the value of alpha. So the first element will be cosine of alpha is equals to 1. And the second equation gives us negative sine alpha is equals to 0. So in order to find out the common value of alpha, which makes both the equation 2, if we consider alpha is equals to pi, it's 2 pi. So 2 pi, then we'll have cosine of 2 pi is equals to 1. Then we have negative sine of 2 pi is equals to 0. So this holds true. Then we can consider some other values of alpha, which is equals to 4 pi, 6 pi, and so on. So we can say that for alpha equals to 2 pi, 4 pi, 6 pi, the given matrix A will be an identity matrix. Let's go to the next question. So in this question, we have to find out the value of x. So we begin by multiplying the 2 by 2 matrix to a column matrix. So that should give us 3 times x, 3 times x plus 4 times 1 is 4. Then we have 2 times x plus x. So that will give us a 2 cross 1 matrix. And this is equal to another column matrix which has the entries 19 and 15. Now, since their matrices are equal, so we can write 6 plus 4 is equals to 19. So we'll solve for x. So 6 will be 19 minus 4. 6 is equals to 15. Dividing both sides by 3. So that should give us 15 divided by 3 is 5. Then we look for the second entry, which is 6 plus x, which is 6, which is equals to 15. So this is also given us x equals to 5. So that will be the value of x. Let's go to the next one. So here in this equation, we have to find out the value of x. So let's begin by multiplying the 2 by 2 matrix to the column matrix. So this should give us 1 times x is x, plus 3 times 2 is 6. Then for the second element, which is this element in the second row, this will be 4 times x is 4x, and 5 times 2 is 10. This is equals to the column matrix on the right hand side, which is 5 and 6. Let's equate that. Since they're equal matrices, the first equation will give us x plus 6 equals to 5. So we subtract 6 from both sides, so that gives us x is equals to negative 1. Now we'll wait for the second equation as well. So this is 4x plus 10. We have to verify that x assumes the same value for both the two cases. So we subtract 10 from both sides, so 6 minus 10, that gives us a negative 4. So we have 4x is equals to negative 4, and we divide both sides by 4 to get negative 1. So since we're getting the both values of x to be same, which is negative 1, so we'll say that the value of x is, therefore x is equals to negative 1. Moving on. So here we have a matrix equation. So using this equation, we need to figure out what's the value of x. So we begin by equating the first entry, which is x plus y equals to 3. So this gives us our first equation. Then we go to the fourth entry, which is the element in the second row, second column, tries of y, and equate it to 6. We divide both sides by 3, 6 divided by 3, that gives us equals to 2. Since we have to find the value of x, so what we do, we substitute the value of y equals to 2 into the first equation. So we have x plus 2 is equals to 3. Then we subtract both sides by 2, so this gives us the value of x equals to 1. Hence, we have x equals to 1. That's it.